We see normally more prominent problems in these coordinate systems in areas, right? Area bounded by a set of lines. This is what we were talking about. Because we define only two lines here. The other lines are not defined in this. Line passing through 2 points is not defined. Area in this may be the area of the part of a circle, defined in circular plane. Area bounded by rho equal to rho 1 and rho is equal to rho 2. It's a lamina. And phi is equal to phi 1 and phi is equal to phi 2 is the normal area that we normally try to compute. Yesterday, I told you the area of the circle through ds. This is actually, if somebody gives you a problem of this type, I am there in xy plane only, but the same plane is actually circular plane also for me. If somebody gives me the problem like, no, this is phi is equal to phi 1, phi 2. This line is phi is equal to phi 1. This is phi 1. This is phi 2. Area in between these two lines from rho equal to rho 1 to rho equal to rho 2. This problem, if you want to do in Cartesian coordinate system, I tell you it's very difficult. Don't attempt only. Don't attempt only because it is not possible to do this problem in Cartesian coordinate systems. Because the vertical strip here will end on this radial line. The vertical strip here will end on the circle from the radial line. Not possible for us to talk about the limits. In Cartesian coordinates, we cannot do this problem, even though this phi 1, phi 2 are defined, and the equation of this part is what? X square plus y squared is equal to rho 2 squared. Equation of this circle is what? X square plus y squared is equal to rho 1 squared. Equation of this line is what? Y is equal to m1x tan phi 1x, because it is passing through origin. Equation of this line is y is equal to m2x. I can define each part of this in Cartesian coordinate system. But it becomes really tedious for us to determine the area. Whenever you see such areas, or the areas of sectors and all, I can even talk about the area which is just like this. Don't attempt to do that problem in Cartesian coordinate system. In circular coordinate system, I will consider ds as rho, d rho, d phi. One order of integration is what? At any rho comma phi, I took this. Take all such areas on the strip of radius rho going in angle from phi 1 to phi 2. So I integrated it first with respect to phi. Such strips are taken from rho 1 to rho 2. One order. Other order is what? Take such strips at the same phi from rho 1 to rho 2 and then rotate that strip from phi 1 to phi 2. Check for the clarity. Not possible to do this problem in Cartesian coordinate system. Here it is what actually? Integral rho d rho d phi from rho 1 to rho 2. This is the strip that I'm talking about. At any phi. Phi from phi 1 to phi 2. It's equal to what? Rho square by 2. It became constant now. And integral d phi from phi 1 to phi 2 is phi 2 minus phi 1 in radian. Definitely phi 1, phi 2 should be greater than phi 1 always. When I basically go right in the limits, no, should be lower value to higher value only. This in radian. Square units. So many. If it is the area of the circle, rho graph goes from 0 to a. So a square by 2. And phi 2 minus phi 1, 5 is what? Total circle is what? 2 pi radians. 0 to 2 pi. You should be in a position to decide before evaluating a particular integral whether to do it. Somebody would have given you the integral in one coordinate system. As soon as you see it, you should know whether to do the problem in that coordinate system or convert if there are x and y, and if you know that the region is such that you can do it very easily in circular coordinate system. You have to convert x and y to circular coordinate, rho and phi. And then evaluate the integral in the circular coordinate system, or somebody has given it in the circular area. But if somebody gives you in the circular coordinate system area of a rectangular circle square, you cannot determine. Using circular coordinates, it becomes really tedious for us. So you should immediately looking at the region where it is being integrated, you should immediately know this is not the coordinate system in which I have to do it. Any other thing that I have to speak about this, no? as I told you. If the surface charge density at any point is xy coulomb per meter square. It's only value. At any point xy, at any point in the two-dimensional plane is xy coulomb per meter squared. Determine the total charge on the surface bounded by on the surface shown. I'll tell you. A simple problem only will take. The surface shown is this. On this. I will be able to show you the distinction here. If I want to do this in Cartesian coordinate system only, somebody has given it like this: x-axis, y-axis. This line is x square plus y squared is equal to 25. I can actually first of all go for vertical strip. What is that now? Integral of x, y is the surface charge density. At any x, y goes from dy. Y goes from 0 to root 25 minus x squared. And to cover the entire area, I have to take such at any x it is of width dx, and the elements going right, small surface elements going from x is y is equal to 0 to y is equal to root 25 minus x squared. Then such strips from x is equal to 0 to 5. Dx. This problem will become what now? Or you can always go from integral 0 to 5. Again integral 0 to root of 25 minus y squared. At any y. This is the horizontal strip that I considered first. xy dx dy. Definitely the answer will not be different. That's what we can see here. Just interchanging the variables is what I did. And that is the problem here. If at least the problem is at least 1/4 of a circular area. This can be done by doing what now? Integral 0 to 5. First integral is what? X into y square by 2 from 0 to root 25 minus x squared dx. What is this value now? Is equal to integral 0 to 5 1 by 2 x into 25 minus x squared dx. This can be done. Then the answer is half of 25 x squared by 2 minus x cube by 3 from 0 to 5.
Sir, x power 4, sir.
X power 4 by 4. Very good. X power 4 by 4, 0 to 5. The value of it is what? Anyway, 0 is not there for us. 625 by 2 now. 1 by 2. Oh, 625 by 8. Answer?
Yes, sir. 625 by 8.
I did it like this. The other way around is what for me? Integral rho cos phi rho sin phi, because x is equal to rho cos phi, y is equal to rho sin phi. Is surface charge density at any point rho comma phi, rho d rho d phi, rho from 0 to 5, phi from 0 to pi by 2. Correct? Because it is only one. What is this now? See the beauty of this problem, I will tell you. Rho cubed d rho, rho power 4 by 4. From 0 to 5 times sin phi cos phi is sin 2 phi by 2. Correct only? Sin 2 phi by 2, which is minus cos 2 phi by 4 from 0 to pi by 2. Correct only? Am I right? Cos pi is minus 1. This is 625 by 4 times by 4. Cos 2 phi is minus 1, 1. Minus of minus cos 0 is 1, which is 625 by 8. Now you have to decide which is better. Mixed problem, actually. Somebody would have given this in XY coordinate systems only. Because it is XY, it is easy maybe. If it were to be XY squared, it would have been different. XY squared, again root will come. For XY, we could evaluate it. Selection of the coordinate system is important, is what you should know from this discussion. Fields is the subject in which, while deriving an expression, you should have taken the appropriate coordinate system for that particular case to get the expression in minimum number of steps and use it in the problems. Same, right? I'll now during the weekdays, right? I will send you sequence of problems every day, and then we will do them on these topics. Another thing that I have to do now. Areas, conversion of vectors. Any other thing is circular coordinates. Now I'll come to actually the three-dimensional coordinate systems, Cartesian, with respect to calculus, as well as cylindrical coordinate systems. And we have to see spherical also. Now, once you see spherical coordinate systems, in fact, those who are studying antennas and wave propagation now gets benefited a lot. Today, we should be in a position to talk about all the coordinate system with respect to the fields. I don't want anything more than that in that. And the integrations of the fields and calculus.